Hi, everybody. Believe it or not, I do podcasts all the time, but I don't have a functioning pen, so I have to try and do this without pen. So, this is Bishop Valley, and I have a question about intermolecular forces, which really the questions were about dispersion and hydrogen bonds, so I want to make sure I go over that. So, intermolecular forces. Intermolecular forces are weaker than intramolecular forces. Intramolecular forces are ionic, covalent, and metallic. Forces by 10 to 100 times. So they are way weaker. Okay? There are three types of intermolecular forces. The three types are dispersion, dipole-dipole, and hydrogen bonds. So dispersion was the first one. Someone said they're often called London dispersion forces. You don't need to call it London dispersion forces, but you can. And they are set up like this. So if I have a helium atom at time 1 and a helium atom at time 2, remember electrons are going crazy. And if by chance the two electrons are on the same side, that side's going to be negative. And that means the corresponding side would be positive. And the atom next to it would have its electrons move to be closer to it. This is the weakest type. It's temporary because it's based on just the energy of electrons going crazy in their shells. It's temporary. It's caused by the fact that electrons are in constant motion and get uneven. All atoms, I should say all atoms and molecules, dipole-dipole is the middle one. It's the middle strength. One end of the molecule is polar, and the other end of the molecule is nonpolar, and it depends on your difference in electronegativity. So some atoms attract electrons more than others. So if you're sharing, say you're sharing a puppy. So if you're sharing a puppy and the puppy likes your dad more than your mom, then that puppy is going to hang out with your dad more than your mom, and your dad would have more puppy time. So if puppies were negative, then that means that your dad would be more negative. And if your mom didn't have the puppy and the puppy's negative, then you're going to be positive. Okay. So here, this is labeled. So the red is showing positive, right? So that means the electrons are over here. This is the more electronegative one. This means less electronegative. And because it's positive, the molecule near it, the positive will be attracted to the negative. Excuse me. They are permanent. When you need two different types of atoms. Bond polarity can be canceled by shape. Hydrogen bonds are the strongest type of intermolecular force. You need H directly bonded to N, O, or F. So what that means is, and I'll put this in here, is if I have H bonded to C bonded to F, does not have H bonds. But C bonded to O bonded to H does have H bonds. And if you are wondering why, well, look, you see how here's an F. Here's F. It is not directly bonded to my friend H. But here they are directly bonded. So that's why you have hydrogen. There's a big difference in electronegativity between H and NO. These bonds are still much weaker than ionic, covalent, and metallic. And I describe them as being the toughest first grader in the world. So if you're the toughest first grader in the world and you try and fight someone who might not be that tough, let's say Kala, and Kala can still beat up the toughest first grader in the world. So that doesn't mean the toughest first grader in the world isn't tough for a first grader, but Kala is stronger than any first grader, just like any ionic, covalent, metallic. Any of them are stronger than even the strongest. Okay. Then we had a question on structural formula versus Lewis dot. Okay, so structural formula, I should stop doing that, but it won't. Structural formula shows the arrangement of atoms, which is chronically rich. So if I tell you that something is CO2, you might foolishly think it is C to O to O. Okay? It really looks like this guy right here. This is the structural formula that shows its arrangement. Okay? So the way this guy is written is NH3. It's written when you're writing it, NH3 is not N bonded to H, bonded to H, bonded to H. So the structural formula shows the arrangement of the atoms. And then Lewis dot structures of atoms. We have this set up right here. This shows a few of the periodic table things. Notice how we have 1 dot, 2 dot. Most everybody turned in the assignment for that and figured out how the dots go. It shows the arrangement of electrons. Okay. It also will show the arrangement of atoms and compounds. To make a Lewis dot structure for a compound, go to this spot right here. So it will be golden for you. And that's one of my things that works on the podcast. You can watch it. So you skip the first 1 minute and 50 seconds because, gosh, we don't want to skip as much time as we can. And that is it. So I will say toodles to you.